Well, I'm going to introduce our speaker for today by just giving you a little bit of his background. He is an internationally recognized specialist on pollution prevention, clean production, green chemistry, and industrial chemicals policy. He's a distinguished university professor and a professor of work environment at the University of Massachusetts Lowell, where he is also the co-director of the Lowell Center for Sustainable Production, which I think many people have really looked at as the go-to place for a lot of questions on alternatives assessment and trying to actually put the principles of green chemistry into a way that can be practiced in real life. This is a center that promotes sustainable solutions in chemicals management and product design. Dr. Geiser is one of the authors of the Massachusetts Toxic Use Reduction Act and served from 1990 to 2003 as the founding director of TURI, which is the Massachusetts Toxic Use Reduction Institute. He's also served as a policy advisor to the EPA and the United Nations Environment Program, and he participates on several boards of not-for-profit environmental organizations. He's also the author of many articles on pollution prevention, toxic chemical policy, and sustainable development, and a book called Materials Matter, Towards a Sustainable Materials Policy. He has an architectural degree from the University of California, Berkeley, and graduate and doctoral degrees from the Massachusetts Institute of Technology. So it was really great pleasure that I introduced Ken Geiser and let him just get into the webinar.
Thank you, Lynn. I thought I had said to try to keep that short. Anyway, it's great. It's great to be here, and I want to thank you and Clinton and folks with the Michigan Green Chemistry Center and the Great Lakes Green Chemistry Network. I really have been very impressed with the kind of programs that you folks have put on, and I'm really pleased to be invited to offer some thoughts on one of these myself. Lynn asked me if I would talk some about alternatives assessment, and I'm pleased to do that. I will try to keep this down to about half an hour, so there's time for questions and all toward the close of this, and I look forward to some engagement about this. It's a pleasure to talk about alternatives assessment because of two good reasons. One is it's an exciting new area of both intellectual and professional work that is going on in the United States in particular, but also now elsewhere in the world. And two is that the Lowell Center has played, I think, a supportive role in this, so we're very proud of the work that we've done and also the people that we've had to work with over the time. And in some ways, Lynn said we're a kind of go-to center, but I think we're only a go-to center because we have had such great support and engagement with many people around the United States in helping to develop this set of ideas. And the next thing I need to do is make this thing, yes, all right. So let's just start. There's no formal definition of alternatives assessment. This is a definition that many people do use. We have used this definition as well a lot. Alternatives assessment is a process for identifying and comparing potential chemical and non-chemical alternatives that can be used as substitutes to replace chemicals or technologies of high concern. The reason why I think that definition is fairly good is it's open, it's pretty flexible. It allows for a lot of different tools to be used in the framing of an alternatives assessment, so I think that we felt good about it. The basic idea of alternatives assessment, though, is to basically reduce risk by reducing hazard. In general, alternatives assessments focus on the hazards of chemicals and the technologies that they deal with, and less so on questions of exposure and risk. The fundamental and underlying principle of an alternatives assessment is to seek to reduce the dangers or the hazards of a substance that we are concerned about, but to avoid a regrettable substitution, to try to assure that the things that we're moving toward are indeed going to be safer than the things that we have today. As far as thinking about the virtues of alternative assessment, I think that it's important because it helps us to focus on not simply what it is we're trying to get rid of, the bad option you might say, but to really look at the choices and opportunities that are around in finding better options. And in so doing, it tends to focus the professional question from one that is focused primarily on getting rid of a problem to really seeking a solution. And seeking a solution, in my mind, is a more creative environment for really thinking about the kind of directions that that we're trying to move in terms of promoting a healthier and safer economy. We assure ourselves that solutions that we're advocating are preferable to the hazards we're replacing. That's essentially the core idea. And we encourage transparency and documentation. The idea of an alternatives assessment is that it is a tool that one can look at, understand the assumptions in, understand the data that goes into it, and that it can be replicated so others could do it as well and try to advance this work. What I think we've kind of said is that alternative assessment, it can be useful to industries that are looking for safer substitutes for substances of concern. It can be useful for governments that are trying to identify the potential alternatives to chemicals that they are trying to regulate or restrict. It can be helpful to chemists and others in the actual scientific area who can use an alternative assessment to help select safer processes and products and production processes. And we also see it as helpful to advocates who can document safer alternatives to chemicals that they may be campaigning on or of concern to them. I say the Lowell Center has been active in this. We didn't actually initially intend to go looking at alternative assessment. We kind of moved into it kind of partly because we were asked by others to provide services in this area. We began in nearly a decade ago with our Sustainable Hospitals project where we were working with Healthcare Without Harm to set up a database for alternatives to some of the chemicals of concern that were being raised by Healthcare Without Harm, mercury, PVC, and latex in particular. We were asked by the state of Maine in 2003 to do a alternatives assessment on mercury-containing products to help them in their effort to pass legislation that would phase those substances out where they needed to be assured that in most cases there were safer alternatives on the market. And with Tim Greiner at Pure Strategies, we did a project in 2004 which was helping the state of Washington, helping the advocates in the state of Washington to help the state substitute for DBDE. Given that history, we found ourselves in a position where we really felt we needed to look at what we had learned from this, and in 2004 we convened a workshop here at Lowell and took a look at what had we learned and what did others know about the idea of alternative assessment, and with the idea that we wanted to build a real tool. We wanted to build a process or a method that could be as robust and valuable to people in our work area as risk assessment and life cycle assessment and other tools have become in the work that we do. And so we held the conference and thereafter published a kind of a framework document, which is available on the Lowell Center website, where we tried to identify the various parts of what a good alternatives assessment might include. In the framework document, we identified 3 different parts. The first was what we called a foundation, the second process, and then modules. In the foundation part, it was really setting out the goals, the scoping of an alternatives assessment. The process was really the comparative aspect of the assessment itself. And the modules were kind of tools that could be used in actually doing the comparisons. Alternative assessment has, over this past decade, also now become a point of discussion in many different places. It was written into the REACH regulation in Europe. written, I might say, somewhat modestly. It appears in the authorization section that says that firms that cannot, that are dealing with substances of very high concern that cannot be adequately controlled need to address the question of are there alternatives that may actually lead to substitution planning. One thing, if people are interested, the European Chemicals Agency has put out quite a nice manual in support of that activity that is now required in Europe. When California passed AB 1879, the legislation known as California Green Chemistry, part of the California Green Chemistry Initiative, it required that firms wishing to sell products in California that had chemicals identified as high priority would be required to do an alternatives assessment, and that included some kind of life cycle consideration. As many of you know, that process of actually writing the regulations in California has taken longer than anticipated. There is now a new version of that regulation that will be coming out here in the next month, which will have a sort of a better documentation on how alternatives assessment will be written into the process that the California law envisions. Let me say a few things about alternatives assessment conceptually, because I think that what we're doing here is really building a tool that can be helpful to decision makers, and it's important to be clear about in building a tool. It's important to be clear about the language that we're using. It's also important to be able to place the tool in a larger context so we can see where it is. But the importance of language and the importance of definition is also critical in order for the term and the terms that are around it not to be misused or not to be confused and confusing to people. So I think that I learned many years ago, particularly in the struggle over the definition of things like of pollution prevention and later toxics use reduction, that struggling on the conceptual side is really important to getting a tool or a definition or a process well recognized and of value to us. For us, alternatives assessment is part of substitution planning, the kind of planning that we first ran into when we were doing facility planning under our pollution prevention or toxics use reduction program. Alternatives assessment kind of evolves out of the substitution planning process. It's a piece of substitution planning. It also aims at, and we use a term here which has been put forward by the EPA, the U.S. EPA, it aims at informed substitution. That is, substitution that really has been looked at and vouched for in terms of the fact that the alternative being selected appears to be safer, to be a more preferred alternative than the chemical or hazard element that is being that is driving the actual alternatives assessment. So we've used both terms, that it's part of substitution planning and its aim is toward informed substitution. We see alternatives assessment as a step-defined process, a process where a practitioner of an alternatives assessment could go through a series of steps, or someone who's learning the process could engage a series of steps that would help them to define their progress through a logic that moves toward the finish of identifying alternatives that are preferred. In so doing, it's also quite useful to focus on things like the function of the chemical of concern, how the chemical actually functions, and to be attentive to the function, because that helps us to define what might also be the alternatives, other things that might function the same way as the chemical of concern. It's also important to recognize that that what we're looking for is substitution, and that it is that that it is a substitution focused on both product and process redesign can be a part of it. And this is just a small note. In an alternative assessment, it's also useful to kind of think about just how valuable the chemical of concern actually is. In some cases, the alternatives may be to do nothing or simply to eliminate the chemical and not really do an alternative itself. This is a little diagram that we use to try to do this kind of conceptually, and I think this will probably work. Let's see here. Yes. The goal, as I said, is the informed substitution. Substitution planning, which is a process that engages many stakeholders in trying to do the planning, is the sort of the process. The method itself then is the evaluation process is what alternatives assessment really is. And then, as I've mentioned before, there are a set of tools or methods that can be used in conducting an alternatives assessment. And that would be the sort of sub-elements of the alternatives assessment itself. Now, thinking about what are those tools for alternatives assessment, we see several, and I think it's important to the way we think about alternatives assessment that the actual comparative chemical hazard assessment, that is the tool that compares one chemical against another, is not an alternative assessment, but it is an element. It is a tool in an alternative assessment. And so there are today among some of those of us that we work with really fine-looking chemical hazard assessment tools like the Green Screen and the DFE programs tools, the EPA's DFE program tools. These are what we would call comparative chemical hazard assessment tools because they really do compare one chemical against another. Other tools that can be valuable are life cycle assessments. This is what's called for in the California legislation. We, of course, think that a life cycle assessment may be a pretty cumbersome tool if it's thought about as a full life cycle assessment, and would prefer to kind of think more that something more streamlined, like a more streamlined life cycle consideration, or what people tend to call life cycle thinking, may be as valuable. There's always some kind of cost and financial assessment to assess whether the alternatives that are being considered or maybe selected are going to be able to meet the cost criteria of the users that are looking for the alternatives, and some kind of technical performance assessment as well, identifying whether the alternatives will actually fulfill the function with the kind of performance standards that is necessary to see them as credible alternatives. We also have left room for or considered the idea that there could be such a thing as a social impact assessment, identifying whether the alternatives have wider effects on the kind of questions of equality and justice and other such things. We haven't seen anyone actually try to do that, but we think that's a likely tool that also could be used. And then, of course, risk assessment might be used in some parts of an alternative assessment. I'll come back to that sort of right toward the end of this. This is a diagram which I'm going to use to help us sort of clarify this and to walk through an alternative assessment. It is a diagram that comes from the work that the Toxics Use Reduction Institute initiated about a little over 2 years ago by calling folks together from the states and thinking about what are the methods that people in the states were learning about in terms of doing alternatives assessment. This discussion was adopted into the Interstate Chemicals Clearinghouse. I'm hoping that many of you know about the Interstate Chemicals Clearinghouse, a now 3-year-old initiative that now includes 11 different states working together to identify the means to more effectively manage chemical information data. If you're not, you might want to check it out. I think I have at the end a website that you can go to. As this discussion was brought into the Interstate Chemicals Clearinghouse, there was an effort to begin to formalize what the lessons were from the states into an alternatives assessment logic or protocol, which was put together in a kind of a wiki fashion so that various people could interact with it and add to it. And it is now part of the Interstate Chemicals Clearinghouse. So you can find this on the web by going to the IC2 website and looking for this alternatives assessment section there. The reason why I think it's important to have some clear diagram like this, it helps us to sort of think about the steps itself, and as you'll see, it helps in thinking about doing education or training around alternatives assessment, because you can kind of go step by step through the process itself. And that's what I will try to do here and give you some idea. Okay, let me just see here. I think, nope, don't want to do that. There we go. I have this feeling I've missed a slide somewhere, so let me just make a comment, and that is the Toxic Use Reduction Institute actually did a very important study right at the time we were doing the international meeting on the alternatives assessment, which was its so-called 5 chemicals study, in which the legislature in Massachusetts had called upon the Toxic Use Reduction Institute to conduct alternatives assessments on 5 chemicals, and this was actually one of the really best grounded ways we learned really the process, or developed and learned the process as we went. I needed to mention that because I'm going to rely on that a little bit as we go along. I'm not sure what happened to the slide to that effect, but let me just say that that was it's supposed to be there about 3 slides ago. The first part of doing an alternative assessment has to do with kind of that foundation part that was there in the original Lowell Center framework. It is really defining the scope and defining the actual goals of the alternatives assessment. How large an analysis are you going to do? What kinds of things do you are important to the analysis? What kind of things would you keep out if you were doing a very simple alternatives assessment on a specific problem in a process, in an actual production operation? You might keep the scope very narrow and try to just find things that would meet that very simple set of parameters at that level. If you're trying to do it at a much larger level, like how to phase out the use of a chemical in an economy, you would have a much broader scope. But it's also a time you really want to be thoughtful about defining the what we call the decision rules, the kind of in particular, what do we mean by safer? How do you find, what are the indicators that you're going to use in trying to determine that a substance may be, quote, safer? That's a pretty difficult term on its just to use in a generic way, and so it's important to be clear about what are going to be the elements of that definition. But of course, other decision rules, like what to do with trade-offs when there are trade-offs, like between energy and toxicity, or between worker conditions or consumer conditions, to try to come to some terms of what are going to be the guiding rules that you use in the analysis itself when you get to those points. The second really step is to get to know the chemical of concern much better, to really identify its characteristics, what is its physical, chemical, hazard traits, etc. What are the things that you're really trying to move away from when you're looking for alternatives? We found that it's really useful to fully characterize the chemical of concern before moving to looking for alternatives. It helps to really know what you're trying to, what are things that you may want to be looking at that might deviate from the chemical of concern in such a way as to provide a potentially preferred alternative. It's really important to identify its uses, because it's, as I mentioned earlier, the functions that it performs are really critical to knowing what an acceptable alternative might be. And it's also important at this point just to screen around to find out what kind of information sources are there that are going to help in the analysis. Do you want to rely on government sources? Have there been other assessments done of chemicals of this chemical or of chemicals, similar chemicals? Do you want to rely on scientific literature? Are there sources in the advocacy community? What is the kind of information that's going to be credible to the kind of assessment that you're trying to do here? The third step has to do with prioritizing the uses themselves and selecting and identifying the uses of the chemical. And this really has, again, if the object of interest is a chemical used in a particular production line, how it's used is pretty narrowly defined. It's not a particular problem at that level. But in the level of the 5-chemical study, for instance, in Massachusetts, where we were being asked to consider chemicals such as formaldehyde, formaldehyde is used in many, many uses. It's important for an assessment to be clear about what uses are the uses that are going to be really the kind of indicative uses, the uses that are the most important to focus on in thinking about what alternatives might exist. It's also important to identify potential exposure scenarios to really have a sense of how the chemical really does, why it is considered a danger itself, and to think about those issues. And then at this point to really identify available alternatives, to really begin to just note what ones are on the market or what ones could be on the market itself. Here's an example of just a piece that came from the 5-chemical study, looking at the uses of formaldehyde itself I mentioned earlier, where basically we looked at a series of uses, narrowed it down to particular uses we felt were really of significant, would be significant indicative uses, and then noted why those uses were really important. The fourth step is really to identify the alternatives and prioritize them. And here, this is a bit of an art, but it is really looking widely for alternatives, which can mean looking at competitors' products. It can mean looking in the trade press. It can mean looking on the web. But the first step is really just trying to find out what might function effectively, be within that looks like it does not have some of the characteristics of concern that the chemical of concern has. And here we have found that it is useful to screen out certain possible alternatives that simply would not fall out well in the further analysis. It's not worth going forward with an alternative, for instance, that's known to be a carcinogen, if in fact the substance that you're considering is a carcinogen, and the goal is to move away from carcinogens. So it doesn't make sense to continue to keep an alternative in the list if in fact would be, by the very design of the process, not an acceptable alternative at the end. So we recommend at least a rough screen at this point to screen out alternatives that simply on their face would not be an acceptable alternative. Hopefully one narrows the list down. To make an alternative assessment effective, it needs to have at least one fully standing alternative. But we find that something in the order of 4 to 5 to 6 is a useful number. Obviously, you could do alternative assessments with several, with 10, 12, 15, whatever, but they get much more complicated. It's useful to try to get it down to some numbers where you can really do the analysis kind of effectively at that point. Selecting the alternatives, as I mentioned earlier, you can, if the decision rule that you struck at the beginning was chemical for chemical, then you only look at chemicals as an alternative. But we would argue that it's sometimes very important to shift out of the chemical for chemical idea of an alternative assessment and take a look at the material that the chemical is in. Is there another material that might function in that way? To look at possible product redesign or process change, or ways to actually eliminate the use or to change the system itself. And it's just a useful, it's kind of mind-expanding exercise to think about other alternatives than simply the chemical for chemical. And this would certainly include what you might call non-chemical alternatives as well. The actual comparison uses those tools that we mentioned earlier, environmental health and safety tools, the kinds of tools like the green screen and the DFE program, DFE tools that have been developed to use tools like the technical performance tools, the economic and financial tools, and others to try to really do an analysis of each of the alternatives compared to the chemical of concern. This is an example of a table that comes out of the 5-chemical study in which we're looking at alternatives to DEHP is used in medical devices. And here you can see on the vertical axis the range of alternatives, in this case 3 alternatives being rated against the DEHP in both terms of performance and cost, and also in terms of environmental health and safety criteria themselves. This is another example. This was one on perc in dry cleaning, perchloroethylene used in dry cleaning. And again, in this case, the alternatives are arrayed across the horizontal axis, and the technical performance characteristics are arrayed along the vertical axis. Where possible, it's useful to try to use numeric data in these. Quantifiable data is always valuable. At other points, one can find specific terms for differentiating between things. Sometimes one's left, though, with just a kind of qualitative or judgmental statement like high, medium, and low. One shouldn't discount a factor simply because one can't find a numeric indicator. Sometimes high, medium, and low can be just as valuable in actually doing the assessments themselves, and we encourage the use of these kind of qualitative indicators as well. Step 6 is selecting the preferred alternative, which really means trying to either use a protocol or, more likely, to use just good sound judgment. What we've recommended is those kind of matrices that you just saw as a way to display data, and that whoever are the actual decision makers about the acceptance of an alternative be involved at this stage in actually looking at the presentations in the graphic form of a table and making selections based on the information that is presented. It's important at this point to refer back to the goals of the alternative assessment to make sure that the alternative is really meeting those goals, and finding ways to indicate amongst the alternatives which ones tend to meet the goals best. You can, at this point, use various kinds of scoring devices, numeric scoring or color codes, or any number of different ways to indicate the relative valuation of an alternative against the substance of concern. The last goes back to substitution planning. I'm not going to say much about this, but the step really moves into going back and trying the alternative out and really seeing if it does meet the needs of the actual setting itself. I'm just going to mention one last piece here, which has to do with, we really believe that alternative assessment should be a multiple stakeholder kind of an event, that it really should engage many parties, that it's more credible, the information is better, the list of alternatives is improved if one is doing it with a group of potentially diverse stakeholders with an interest in the chemical of concern and its potential substitution. And on that basis, when we did the 5-chemical study, we kept a very open process, brought in many people. It obviously slows processes down. It also sometimes makes processes more contentious and difficult, but on the other hand, it enriches the process. I felt that was really important. So let me sort of close so that there's some time for some questions by hopefully having run through the basic framework of an alternatives assessment and maybe some of the thoughts on how they could be used, we see this as still a tool or a method that's under development. It's being moved forward. The California initiative will definitely advance it in the U.S. What Europe is doing on this is going to also advance alternatives assessment, and the work that many people here in the U.S., some of whom are probably on this phone call, are doing is also going to advance this. We think it's really valuable to those of us who are seeking conversion to safer and more sustainable kinds of production. But we also recognize, like any tool, that it can be captured and misused, and it's important that we be alert to that and also be attentive to not allowing a tool to the misuse of a tool to damage its credibility. Just along that line, we already know that there's efforts to start to look more seriously at alternatives assessment by, shall we say, those who are happy with the status quo, and sort of wonder whether this is going to be of value or of hindrance to their particular agendas. And so I think that it's a tool that can be potentially very useful, but I think it's also nothing more than a tool. And so I offer it as, I hope, something of interest to you, and this little discussion may have opened up some opportunities for thinking about its value generally. I list here some of the websites that you can find out more information on. So with that, I'm going to just sort of close up and say thank you and open this up, hopefully, to some questions.
Thanks so much, Ken. Yep, we've already got a bunch of questions here. So I'm just going to start reading them in order and let you answer each one as we go along. Ken, as you talk about the AA process, I'm struck by the apparent emphasis on individual chemicals. One of the things that public health and union OHS advocates have pushed for is to deal with chemicals in a broader way, as a class and other groups, etc. What advice do you have about how to effectively use AA in this broader way?
Well, first of all, I'm kind of sympathetic to that, the spirit of that. I also agree that as we move forward, we're going to have to find ways to handle chemicals in more than a chemical by chemical sort of approach. And so it puts me in somewhat of an embarrassing moment to sort of say that generally speaking, alternatives assessment has been used at this point on a chemical by chemical approach, and that's about the level of development that I think we're at this point. It's an interesting challenge to think about how it could be used more to deal with chemicals as a class or groups or families of chemicals. It's, I would say, enough of a challenge at the moment, just as I mentioned, with the multiple uses of even a single chemical like formaldehyde or something like that, because so much of the success of an alternatives assessment is kind of situationally driven. That is, does it really meet the functional needs of a particular use? It's sort of daunting, but certainly worth an interesting challenge to think about how you would think about, say, if you were going after all brominated compounds or something like that, how you would use alternative assessment. But I'd leave that as a challenge a bit for the future.
Great. So I have a next question is, hello, Mr. Geiser. The presentation was very enlightening. Thank you. I'm pursuing an Master's Tech in Green Technology. I would like to know about alternatives to the non-green reagents used in batch sulfonation processes. I hope I pronounced that right. One that I know of is silica sulfuric acid. It would be helpful if you could also tell me about new, greener methods for batch sulfonation.
First of all, that's a really interesting set of questions, but I think for another webinar. I'm not going to be an expert on that itself, so I'm not going to be able to tell you that. I think there are obviously various sites that you could look at. I know that I've looked at recently at the MIT, what is it, Green Wizard, or where they do comparison of lab chemicals, and some of that would, I think, appear in that website. That might be interesting to look at, but it's too, first of all, I wouldn't be an expert on the subject, but secondly, I think it kind of diverges from the process level that I'm trying to stay at here. Thank you, though, for the question.
So if the person who did that question, I'm not going to try to pronounce your name because I know I won't do it right, and I apologize. But if you would email me at glgreenchemistry@gmail.com, I'll see what I can do about, maybe finding somebody who can address that question. So are there other questions? You raise your hand or type a question into the question box here. Well, I'm really encouraging people to take advantage of this with Ken. But I don't seem to have any hands up. Maybe you just covered the field so...
I don't know. I hope it was enlightening. I hope it was valuable to you. I would encourage people, if this is just closing up, I would just encourage people to get involved in thinking about alternatives assessment. I assume some of you on the network are involved in industry, and it would be very valuable to see, to hear more cases. We're doing an effort at this point to begin to develop a compendium of alternatives assessments where we can have a basically portal where we can kind of array a lot of them under this wiki itself, so that people could sort of be able to go to a central place and look and see if there are other alternatives assessments done on the substance of their interest. So if you were interested in some of that kind of work or wanted to join with the IC2 in the development of the actual process of this alternatives assessment, I would certainly encourage you to do that. So please, if this is of interest, let us know, and we would very much welcome your contribution to it.
So I have another question. Any thoughts on how to pursue social aspects?
I don't have the reference here. The UN has been, UNEP has been doing an interesting body of work on looking at social impact assessment, and to the degree that it is focused on chemicals. If you were to, whoever's asked this question, if you were to email me at, I don't know, is there an email address? I guess I don't have one there. I would try to get you the actual reference on that I think is an interesting place to look for that.
We have lots of questions now, so I'm going to try to get through them. Do most DFE models include a chemical list of some kind? I would answer that myself and say that in January we're going to have Clive Davies from DFE as our presenter, so be sure to come back then and you can get some more besides what Ken will answer you now.
Yeah, I think if you look at the DFE process, first of all, there's the DFE Design for Environment process, office at EPA has been a leader in developing alternatives assessments. They both have been a leader in the actual methods, in particularly of comparative chemical hazard assessments. And I know I'm involved at this point with several people there and others who are thinking about actually putting together kind of a little textbook on this subject. But they've also been a leader in actually doing particular sectors, industrial sectors, furniture, foam, and others. And in those cases, there really are lists of chemicals, so you can see the actual lists. And if you go on the website, you can see those sector analysis. They're very, very good and very revealing. So yes. And having Clive on would be great, and that's a great idea.
As a person working in public health, how do you suggest that we do outreach to inform people about alternatives assessments?
Well, I think first of all, knowing that it exists, that people, that when confronted with chemicals of concern, and people in the public health movement are often confronted with substances which they believe are hazardous, and sort of hazardous in the public, either in the commercial market or in food or whatever, to be able to say that there are safer alternatives and then to be able to back it up with some kind of a tool, I think is an asset in sort of the struggle for improving public health. So knowing about alternative assessment and being able to say, hey, why are we trying to deal with an exposure control method at this point when in fact we maybe should just try to get the chemical of concern out of this set of products or this environment, and that there are really tools like alternative assessment that can be used in that, I think is of value. So I think it's just knowing about it and advocating the use of an alternative assessment.
I have a couple of questions here that are sort of the same, so I'm going to read them both. I may have missed it on the slide, but at what point does cost of alternative play a part? And then I had another question. Thoughts on whether elements of the ultimate decision process can be, let's see. No. Are you an advocate for including external costs in the economic part of the alternatives assessment?
Well, let me just start by saying the cost assessment itself. Yes, you may have noticed one of the modules is really cost assessment, and in the work that we did at the 5-chemical study or in even the considerations that we're doing in California, cost does play a role in that. And it's important to do that, to do cost assessments, because in doing the substitution planning and actually implementing a credible alternative, one wants to be able to argue that it is cost effective. Cost, though, is kind of fungible, and performance characteristics can be as well, but they tend to be more rigid. The cost itself of an alternative on the market, first of all, one can look at the direct price, which is one way to think about a cost analysis. But it's much more credible to look at the costs, including some of the external costs, such as the life cycle costs or the total cost in regards to how the alternative would reduce the costs of other kinds of overhead costs, such as obviously worker health and safety, or in the case of a production plant, or compliance costs or others. So doing a cost assessment is really pretty important, but one should go beyond just a price assessment.
Thank you for your excellent talk. Can you comment on how you would approach an alternatives assessment on chemicals or technologies that have a less robust database than some of those discussed today, for example, nanomaterials?
Yeah, that's a good question. What happens when there's lots of uncertainty in an area? And of course, nanomaterials would be a good example of that. So you've locked onto a really good question there. Obviously, if there's not going to be a lot of information and it's hard to extrapolate from other sources, you're going to be in an environment in which a lot of the data parts of an analysis are missing. It may be possible in some cases to do high, medium, low, to do kind of qualitative estimates to get some picture of something. Or it may be that an alternative assessment, and here I'm going to say something, just may not be that useful because there's not enough information. For instance, a risk assessment on some of those situations is also not useful. If there's not enough information, one shouldn't let the tool become an excuse for not having the information. You can develop good tools, but if you don't have the information, you need to admit that and start from a different question, which is how do you develop that information?
That's really interesting. What is the future of alternatives assessment? In addition to figuring out how to look at chemical classes, do you see other challenges on the horizon?
I'm really glad to get that question. That's a great question and a good one to sort of begin to close on. Because I have said, like, beware. We know some lessons from watching what happened to risk assessment and watching what is potentially happening to life cycle assessment that ought to tell us something about how we as a culture actually use these tools. One of which is that we try to tie these tools into regulatory operations, in which case lawyers start to define them, and they define them very tightly and very rigidly and take a lot of the flexibility out of the tool. So it's important to be thoughtful about how quickly we should be integrating a tool like this into legal doctrine. I think this is one of the errors that got made with risk assessment. Secondly, you can get overly scientized. I love fields of science, and as a scientist, I'm very strong on it. But you don't want an alternative assessment to be completely tied up in endless search for information and unable to move forward on steps because there's just not enough information. It's really important to go with what information you've got and not to feel like you've got to have perfect science on everything. So I think keeping the tool open and flexible and usable is really important, and one of the struggles ahead will be to try to maintain that kind of openness and exploratory nature of the tool itself. I urge us not to try to clamp these things down too rapidly. But that, along with trying alternative assessment in different kind of places, how useful is this on technologies themselves? How useful is it in thinking at the material level and things like that are all questions that I think are going to be interesting challenges for the future.
I'm going to try to sneak one more question in. We had a lot of questions, and I'm really sorry that we didn't get to all of them. I may send them to Ken later, and maybe if he has time, he'll answer them, and we'll put them on our website or something. If there is secrecy in industries about their inventions, that is, new chemicals or catalysts which may be harmful for the ecosystem, how can transparency be encouraged in this case?
It's a question that stands outside of alternative assessment, but it's a question that affects alternative assessment, obviously, and that is, we have historically relied on confidential business information protections for information that a business might feel was a competitive that they would be a competitive disadvantage if they were to reveal. We know this tool really has been overused. In particular, has been overused within submittals to the EPA under TSCA, for instance. We've got to find a more credible way to handle confidential business information, one that actually does protect what is truly the competitive business information, but has a more rigorous test to assure that only the information that really is of competitive nature is protected. And secondly, some kind of a window of time that one shouldn't just assume that something is confidential at a moment and then forever after. That as we progress in science, as we develop technologies, information that once was more private becomes silly to continue to keep it confidential. To that degree, then, it affects alternative assessment, and that is if you're just going to come up against things where the information on an alternative is simply not available because it's protected confidentially. I think it's always worth a challenge. Say you're looking at an alternative, you go to the manufacturer of that alternative and say, we really would like to consider it in our assessment and all, but you don't put anything out as to what is actually the composition of this mixture or the processing of this particular material. I think it's worth a challenge to say we would consider your alternative as a credible alternative were you to give us more information. So I think you can always use it a bit as a driver, but that would be the best that I could answer there.
Thanks, Ken. This was really outstanding. We really appreciate your taking the time to do this with us. And you can see there were a lot of questions, and I think a real lot of interest in this subject. I want to remind everybody that you can find out more about our series at www.glgc.org, and you can also go to the Michigan Green Chemistry Clearinghouse website at migreenchemistry.org.